Assalamualaikum warahmatullahi ta'ala wabarakatuh. My name is Salib Margina Malim Toha, and now we will discuss about the human mind at work. Psycholinguistics is the area of linguistics that is concerned with the linguistic performance, how we use our linguistic competence in speech production and comprehension. The human brain not only acquires and stores the mental lexicon and grammar, but also access that linguistic storehouse to speak the understand language in real time. How we process knowledge depends largely on the nature of that knowledge. If, for example, language was merely a finite store of fixed phrases and sentences in memory rather than an open-ended system, then speaking might simply consist of finding a sentence that expresses a thought we wish to convey. Comprehension could be the reverse, matching the sounds we hear to a stored string that has been memorized with its meaning. But it is not possible because of the creativity of language. When we speak, we access our lexicon to find the words, and we use the rules of grammar to construct novel sentences and to produce the sounds that express them. When we listen to speech, we also access the lexicon and grammar to assign the structure and meaning to the sequence of words we hear. The grammar relates sounds and meanings and contains the units and rules of the language that make speech production and comprehension possible. However, other psychological processes are also used to produce and understand utterances. Various mechanisms enable us to break the continuous stream of speech sounds into linguistic units such as phonemes, syllables, and words in order to comprehend a message and to compose sounds into words in order to produce meaningful speech. Other cognitive mechanisms determine how we pull words from the mental lexicon, and still others explain how we assemble these words into a structural representation. Ordinarily, we have no difficulty understanding or producing sentences in our language. We do it without effort or conscious awareness of the process involved. However, we all had the experience of making a speech error or having a word on the tip of our tongue, or failing to understand a perfectly grammar sentence such as in the following sentences. On hearing the first sentence, many individuals will judge it to be ungrammatical, yet they will judge as grammatical a sentence with the same syntactic structure in sentence number 2. Similarly, people will have no problem with sentence 3, which has the same meaning as sentence number 1. Conversely, some ungrammatical sentences are easily understandable, such as sentence number 4. This mismatch between grammaticality and interpretability tells us that language processing involves more than grammar. A theory of linguistic performance tries to detail the psychological mechanisms that work with the grammar to facilitate language production and comprehension. Now, let us proceed to comprehension. But before that, I want you to read the following sentences. Did you understand what it means? The sentence uttered by the Duchess provides another example of a grammatical sentence that is difficult to understand. The sentence is very long and requires extra resources to process owing to the multiple negation and the multiple use of otherwise. Alice notes that if she had a pen and paper, she could unpack the sentence more easily. The various breakdowns in performance, such as tip-of-the-tongue phenomena, speech errors, and failure to comprehend tricky sentences, can tell us a great deal about the processes people normally use in speaking and understanding language. Just as students' acquisition errors tells us a lot about the mechanism involved in language development. Now let us proceed to the speech signal. Understanding a sentence involves analysis at many levels. To begin with, we must comprehend the individual speech sounds we hear. We are not conscious of the complicated processes we use to understand speech anymore than we are conscious of the complicated processes of digesting food and utilizing nutrients. We must study these processes deliberately and scientifically. One of the first questions of linguistic performance concerns segmentation of the acoustic signal. To understand this process, some knowledge of the signal can be helpful. Physically, a sound produced whenever there is a disturbance in the position of air molecules. Objectively, a sound is produced subjectively. No sound is heard. In fact, there are sounds we cannot hear because our ears are not sensitive to the full range of frequencies. And now let's proceed to speech perception. Speech is a continuous signal. In natural speech, sounds overlap and influence each other, and yet listeners have the impression that they are hearing discrete units such as words, morphemes, syllables, and phonemes. A central problem of speech perception is to explain how the listeners carve up the continuous speech signals into meaningful units. This is referred to as the segmentation problem. Another challenge is to understand how the listener manages to recognize particular speech sound when they are spoken by different people and when they occur in different contexts. For example, how can a speaker tell that a D spoken by a man with a deep voice is the same unit of sound as the D spoken in the high-pitched voice of a child? Acoustically, they are distinct. Indeed, no two voices are identical in very detail. Similarly, a D that occurs before the vowel E is somewhat acoustically different from a D that occurs before the vowel U. Even within a single speaker, the physical properties of the same sound vary from utterance to utterance depending on the phonological context and even the state of health of the speaker. How does a listener know that two physically distinct instances of a sound are the same? This is called the lack of invariance problem. Despite this problem, listeners are usually able to understand what they hear because our speech perception are designed to overcome the variability and lack of discreteness in the speech signal. Experimental results show that listeners calibrate their perception to control for speaker differences and can quickly adapt to foreign accented or distorted speech. When listening to distorted speech, for example, listeners need to hear only 2 or 4 sentences to adjust and can then generalize to words they have never heard before. It takes about a minute to adapt to non-native accents. Similarly, listeners adjust how they interpret timing information in the speech signal as a function of how quickly the speaker is talking. These normalization procedures enables the listener to understand a D as a D regardless of speaker or speech rate. Listeners can exploit various acoustic cues in the signal as well as relationships among different acoustic elements to get around the lack of invariance problem. For example, the frequency of the first or lowest formant for A is high relative to E and U, though the precise values may differ among speakers. Additionally, certain types of speech sounds have characteristic properties that can be relied upon for identification. Stops have a brief period of silence followed by a burst. Fricatives produce high-frequency noise, and vowels are associated with particular formant structures. These acoustic cues